Question number 15 of exercise 1.2. It goes like this. For what values of n? They are asking you to find out the value of n. So what value of n among the two different APs? One is 63, 65, 67, so on, and another AP which is 3, 10, 17, so on. If you come to the nth term, I'll call the nth term of the first AP as an. I'll call the nth term of the second AP as bn, because they both are different. We want to show that these two terms are same, means an is equal to bn. This is what they are giving you. This is the given data. That is, the nth term of A, or the first one, is equal to nth term in the B series, second one. So if they both are equal, what is the value of n? So it is very similar to one of the previous problems we solved. Only small difference is their difference was given both are equal. Here difference is not equal. See, here the difference is smaller, whereas difference is bigger here. So they both don't have the same difference. Then D is different. If I call this one as D1, I'll call this as D2. Two different Ds. The first terms are different. I'll call this as A, this as B. A is 63, B is 3. So let me try to compare both of them separately. I'll write here above this as the first series. A1, A2, A3, so on, AN this is. And for this one, I'll call it as B1, B2, B3, so on as Bn. Now let us compare and write. In the first one, if I write the formula, An formula, if I apply, An is equal to A, which is 63 plus n minus 1 into difference. What is the difference? Let me find out the first difference. I'll call it D1. D1 is equal to A2 minus A1. A2 minus A1, which is 65 minus 63, which is equal to 2. So this is the difference, first difference. Okay. Let us go to the second series and check there. In the second progression, Bn is equal to B, which is nothing but 3, plus n remains same because nth term, suppose it is 50th term I am talking about. I want the 50th term in both of them, in the both. So n should be same in both, into difference, that is the difference between the terms in the second one. So I'll call it as D2, which is equal to B2 minus B1. What is B2? B2 is 10 minus 3. 10 minus 3. How much is 10 minus 3? That is 7. So this difference is 7. Be very careful here. The difference in the first series is 2. The difference in the second series of this progression is 7. In this case, let us simplify further. What is An is equal to? We know that these both are equal. Okay. They are given that these two are equal. Then find the nth value. So if these two are equal, then the right side also should be equal. These two also should be equal. So I'll equate these two. Why? Did you understand? An is equal to Bn. But An's value is this and Bn's value is this. So these two also must be equal according to the axiom. Equals which are equal to the same things must be equal to each other. So 63 plus n minus 1 into 2 is equal to 3 plus n minus 1 into 7. Simplify this further. 63 plus 2 into n. Apply distributive property. 2 into n is 2n minus 2 is equal to 3 plus 7n, again distributive property, minus 7. 63 minus 2. 63 minus 2 is 61. 63 minus 2, 61 plus 2n is equal to 3 minus 7. So 7n. 3 minus 7 is minus 4. Please remember 7n is independent. 3 minus 7 when you subtract you get minus 4. Now I'll take 2n to this side. So it will become minus 2n. I want the variables on one side, constants on one side. This minus 4 is a constant. I bring it to the other side, becomes plus 4. So 61 plus 4. See, 4 comes this side, becomes plus 4. 2n goes that side, becomes minus 2n. Further, I'll just solve it above here. So now 61 plus 4, 65, which is equal to 7n minus 2n is 5n. 5 comes to this side, becomes divided by 65 by 5 is equal to n. 5 ones are 5, 1 carry 15, 5 threes are 15. Answer is 13. So n is equal to 13. So we can say that the 13th terms of both the APs, 13th term, we have not found out which is the 13th term. I am just saying the 13th term in both the cases are going to be equal. If you want to find out the 13th term, you can apply in any one of them. Any one of them, you will get the answer. Let us try to find out that 13th term now. So we know that 13th term is equal. 13th term in both of the arithmetic progressions are equal. They have only asked which term, and it is 13th term. That is enough. Answer is enough. Just to know by curiosity which is that 13th term, we can find out extra. That they have not asked in the question. I am just asking you to just go one extra mile. That is, an is equal to a plus n minus 1 into d. Right? An is 13th term. I want a 13, which is equal to a, which is 63 plus 13 minus 1 into difference is 2. So that is equal to 63 plus 12 into 2, which is equal to 63 plus 12 2s are 24, which is equal to 87. We could check whether this answer is correct just by applying the same formula for the nth term in B also. If you just try, you will get the same answer. You can of course verify. Thank you.